variance because the definition for variance is the formula itself. I just want you to have your basic understanding of variance is that it's based on a difference or a distance that each data is from the mean. Okay. That's a very broad definition, by the way. Okay. I don't want you to think this is the be all and end all, because if you look at the definition that the book gives you, it's literally the formula for variance, which I'm about to write, and you're going to look at that and be like, whoa. Okay. So there are 4 formulas that you're going to see right now. Please don't get scared. They're not scary. They look scary, but they're not scared. Okay. There is sample variance, and then sample standard deviation. Sample variance and sample standard deviation. And it looks like this. S squared equals sigma of x minus x bar squared over n minus 1. Not scary at all. Not scary at all. Okay? Now, there are some things in here that you actually know right now. I know it doesn't seem right, but it does, okay? What is x bar? We just learned that. Mean. That is your sample mean. So they're going to give you sample mean, or you're going to find the sample mean. Very easy. The n right here is your sample size. Think of it, whenever I see an n, I think the number of data points, the number of people in the data. N is always a size of your sample, okay? This x, that's all by itself, is one of your data points. So like we're talking about grades in my class. If you got a 96, but the average was 92, so I would do 96 minus 92. Okay, so x is an individual data. Anybody do you know what sigma means by any chance in math? Do you remember, anybody from last year, what this means? This actually means to sum. You want to sum up all the subtraction of each data value from the mean, square it, and then divide by the number of data minus 1. And you're probably thinking to yourself, we're going to have to do this by hand? Uh-huh. Sorry. Not sorry. Ready? Sample standard deviation. The square root of the sum of x minus x bar squared over n minus 1. Mathematically, tell me the only thing I just changed. That's exactly it. Once you figure out this, all you have to do is take a square root.
It would just be sigma times blah, 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 blah. And take off the square?
No, because you're doing the sum of each of these. It would be if I was multiplying, but I'm doing the sum of it. Okay, good point. Good question. Now, you use this when you have less than 30 sample size. 30 is your magic number, okay? You use sample variance, sample standard deviation when you have less than 30 things. 30 grades, sample standard deviation, sample variance. 30, that's your magic number is 30. 30 and under, you use the S. Okay, now we're gonna write population variance and population standard deviation. And I just want you to notice one thing that changes here. Population variance, population standard deviation. So So population variance is written like this. This is called lowercase sigma. It looks like a O with a hat on it, like a little extra hat, squared, equals the sum of x minus mu squared over n, capital N. What does that look like to you? Does that not look similar to this? What's my mu?
Mean.
That's the mean again, right? Of the population though. Why is it n and not n minus 1? Because in a population, in a sample, you have to take away one. It's called a degree of freedom. We just take it away to kind of give ourselves a better accurate number. Whereas in the population, I don't need to take that away, okay? So again, if on the side of your paper, this is what you're going to write, just to kind of give you an idea here. Mu is the population's mean. X, well, that's that individual data again. And N is your sample or the size of your population. Which could be crazy. You're like, what? There's a size of the population? Yes. Again, your population can change from like MCA students to like just the boy MCA students, that kind of thing. So that's why your population can be different. What about the O? That's just a Greek symbol. It's called sigma. It's a lowercase sigma. Remember, they use Greek for population, and then they use regular letters for samples. There's really no change. There's nothing to be different. What do you think population standard deviation would look like? Just an O and put a square root on top. Now, yes, this is in the calculator, but I will let you use the calculator. I'll show you how to do it, but you have to do it by hand for just the 3 problems and then on the quiz. I'll let you use the calculator so you can see if you got it right or not. So it'll be a really nice, easy thing. Again, what is this all based off of? This is based off the difference that data point is away from the mean. How far? I don't want a large variation of grades. I don't. I want a small variation of grades. I don't want like the average in the class to be, a 96, but, everybody's variation was by 10. I'm like, oh, that's not good at all, or whatever. All right, so we're going to do one quick example, and then you do not have to do this part of the homework, but you'll be fine. So this wants you to find the range, the variance, and the standard deviation for, I'll give you some data points, 10, 60, 50, 30, 40, and 20. Now, is this under 30?
Yes.
So we're going to use S. We're going to do a sample. So number 1, we'll start with the range. The range is really easy. What's the range here?
50.
Yeah, 60 minus 10. That's simple. Okay. Once you find the range, to find the variance and the standard deviation, the first thing you're going to need to find is a mean, because if you notice in all of our problems, we had a mean. Okay. You can use the calculator to find the mean. This is so small that you could probably find it yourself right now. I'm going to give it to you, but your mean, also known as your X bar, because we're doing a sample, is 35. If you don't trust me, just do. Just trust me. Just trust. Okay? Then you are going to have to, by hand, do this for the 3 problems and for the quiz. Once we are done with the quiz, you will never have to do it by hand again. I force you all to do it by hand because I know for a fact in every stats course, even the ones that like Noah Threet just had from UNCC, he had to do it by hand. Okay, it's just what they do. I don't know why, because honestly, the calculator will do it for you. But you're going to make this chart. The chart looks like this. X minus mu, actually, sorry, not mu. Sorry, I get very, X minus X bar. It doesn't matter. X will be the same. And then X minus X bar squared. That's your chart. X minus X bar, X minus X bar squared. Why am I doing 3 things? Because these are all in the formula that I just gave you before, weren't they? An X was in there. Wasn't an X minus X bar there squared? Okay, so some of you might not have to do this. I remember Niles last year, he hated this whole column, so he would just skip to this one. I was like, okay, Niles, whatever makes you happy as long as you're getting it right. And you'll see what I mean. So X, again, is each individual data point. So you're going to write each individual data point right here on X. 10, 60, it doesn't have to go in order. 50, 30, 40, 20. Easy. X means X individual. What does this mean? You should know this. Mathematically, what is this saying? Take your X minus the mean. Take your X minus the mean. Take your X minus the mean. So what is that? 10 minus 35, which is negative 25. 60 minus 35, which is 25. 50 minus 35. And again, like I said, Niles hated this right here. He would just skip to this row. What does this row say to do? Square what? That number, right? So negative 25 squared is 625. 25 squared is 625. You should never get a negative on this answer, by the way, because you're squaring negative numbers. So it's always going to be positive. 15 squared is 225. Figure out these last three right here. Take the individual data, subtract the mean. Take the individual data, subtract the mean. Individual data, subtract the mean. Actually, I gave you nice ones. 25, 25, and 225. Would you all agree? Okay. Now, just because I want you to look back over here. To get the sample variance, I have to sum what? What is that? That's that last column, right? The sample variance says to sum the X minus X bar squared. So that means take this whole last row, and sum them. So somebody with their calculator, sum that for, oh, you're so smart. 1750. Now, let's look again back at the thing. I'm going to divide it by n minus 1. N minus 1. N means the sample size. How many things were in my sample? There are 1, 2, 3, 4, 5, 6, right? But I don't divide by 6. I divide by 6 minus 1, which is 5. So what's 1750 divided by 350? That right there, my friends, is called your S squared. That is your sample variance. How do I find the sample standard deviation then? Square root that. Square root of 350. What is it? 18.7. That is your sample standard deviation. And that's how they do it by hand. Now, how could I have checked this in my calculator? Real quick.
So I'm just learning to be a slower calculator.
No, you're learning by hand why you are doing this formula. Where did this formula come from? Okay. Got to learn it by hand in order to appreciate what the calculator can do for you. Go to Stat, Edit, put these numbers into L1 again. So 10, 60, 50, 30, 40, 20. Okay. And then do exactly what you were just going to do before. Stat, Calc, 1 vars. Enter, enter, enter. Do you see something there that has an 18.7? That right there in your calculator where it says SX is the sample standard deviation. If I wanted to find this number, I would just take 18.708, whatever, and I would square it to get the 350, the variance. Do you know what that O is? Population. What is the only difference that they're doing? They're dividing this by n as opposed to dividing it by n minus 1. Okay, that's really the only difference. You can have the answer then on the test very quickly by then just reading this off the calculator. But this is how we do it by hand. You have to learn how to do it by hand because you need to understand the variance is how far you are away. The mean is away each individual data point. How far are we varying? What are we changing here? Okay. But you do not have to do this homework, but you can see how long it could take you. I only gave you 3 problems of it. We will do this on Friday when I see you again. But your homework for tonight is just to do then page 122. I'll send out a text because I know you appreciate them. Okay, just do these. Get this done for me so that way you maintain my love. You laugh, but this is true.